Oh, okay. On the same one? I haven't regraded it yet. I will, and it'll fix it. Yeah. Yeah. All you need to know is that if you put in a right one, when I regrade it, 100% sure it'll get correct. Yeah, every time. Okay, here we go. Okay, so let's take a look at this. Now, if we want to solve, we're going to look at solving polynomial equations. Some of the time we're going to factor, and some of the time we're not going to. The book sort of focuses on factoring, understandably, as the main way of solving polynomial equations, but we don't always have to. Now, this I don't really like this in a way because we're going to learn, coming right up in Chapter 7, we're going to learn a way to isolate x here. That's going to be the best way of solving this equation. So I'll be right up front with you and tell you that what I'm showing you right now, honestly, isn't really the best way. I'm not going to emphasize these on the test for that reason, because we're going to find a better way to do this in the future. Now, what do you think in Chapter 7? Before we jump in and do a Chapter 6 method here, what do you think we're going to do in Chapter 7 to isolate x there? First, we're going to... Yeah, okay, well, but how to get x by itself, what would we do first? Divide by 32, good, and then cube root it. That's what we're going to do, right. Okay, now there are some, when we do roots other than square roots, like we did in Chapter 5, there are some things that we got to be aware of when we do that, and so before we jump in and start doing that technique, we need to spend some time in Chapter 7 talking about fractional exponents and how it all works, but eventually that's going to be our best strategy for solving for x here. However, in Chapter 6, there's another way that's not bad. What could we do in Chapter 6? If we're not going to isolate x, we must add or subtract 4 from both sides, right? Yeah. So we'll get 32 x cubed minus 4 equals 0, and then factor this side, right? Now, how many terms, when we see, how many terms are there in that polynomial? 2. So 2 terms means factoring pattern, right? So we have to just find a factoring pattern that fits that. So which one, let's quickly review what our factoring patterns are. We've got a difference of squares, easy one, what's that? A squared minus b squared factors into what? A plus b times a minus b. Good. Now, what about a squared plus b squared? No, does that one factor? No, that's the one that doesn't work.
A squared plus b?
It doesn't work.
No, it doesn't work.
Never works. Okay. What about a cubed plus b cubed? In fact, let's do both of these at the same time because they go together. A cubed plus b cubed and a cubed minus b cubed. Remember that they factor like that. Now, what are the terms in each factor? In the first little factor, we have, what goes here? Okay, a, and then a b. We'll put the signs in just a second. So we get an a and a b, and then what do we get in the big factor? A squared goes in the middle. And then b squared. Good. Now, if we put the signs in, we know that the first sign goes with the first sign, right? Yeah. So that always matches that. So that's a plus, that's a minus. And then from here to here, it switches signs, right? So that's a minus, and that's a plus. And then what always goes here? Plus. Okay, so there are our patterns. Now, which of those patterns could work here? If I've got an x cubed in the first term, which one are we obviously looking at? I've got something x cubed minus something else. That looks like that's got to fit a difference in cubes, doesn't it? That's the only candidate here. Okay, but there seems to be a little bit of a problem. 4 is not a perfect cube, nor is 32. Okay, but we're missing something here. Yeah, greatest common factor. We always want to try to factor out a greatest common factor to make things easier. Now, in the case where we've got something equal to 0, if I factor out a 4, right, that's the greatest common factor. If I factor out a 4, what am I going to get?
8x.
Good. If I divide 4 out of the first term, I get 8x cubed. And what about the second term? 1. Okay. Now, factoring out a 4, then what can I do with that 4?
2 cubed x cubed minus.
In there, you're right. Okay, you're jumping ahead. Now, what about this constant 4 out front? Is that going to have any impact on our answers? No, it's a number. There's no variable there. Now, here's a rule you got to remember in algebra that's going to come up again and again in your algebra lives. It's okay to divide both sides by a number, right? I can get rid of a number by dividing both sides by 4 in this case. So if I divide the left side through by 4 and the right side through by 4, 4 over 4 cancels. What's 0 over 4? 0. I didn't really even have to write that out, did I? I'm going to go back a little bit so I can save a little space. If I just divide both sides by 4, the 4 goes away. Okay? In fact, did I even need to factor it out if we look back one step previously? I could just cut it right out. I could have just said, in fact, being as 4 divides into both 32 and 4, I could have just divided both sides through by 4 and just gotten that result. Just gotten the result, 8x cubed minus 1 equals 0. No, but that makes it easier to get the answer. That makes our polynomial smaller and easier to deal with, right? Now that might not seem like a big deal, but I think that's a very big deal. Does everybody understand what I'm saying there? I need to know if you're following me on this. Okay?
Can you just isolate x and his answer? Like, do I have to do like this on this?
Well, okay. What would you have done? I'll tell you what. If you wanna isolate x, I'm okay with that. You don't have to do it this way, because all the problems that we're going to deal with are ones that you could do by isolating x. We're going to run into some in chapter 7 that are a little harder to deal with, and we'll have to talk about those. But if you want to, I guess I'm fine with that. It really probably is easier. Yeah. So I guess I'm okay with that. Yeah, I know. It's hard to figure out how to do this best, because I think you need to see these patterns, but we don't use them that much. But it's good to be aware of. So here's my point. Everybody, please pay attention to this. So I didn't need to do all this stuff. What I could have done instead is I could have just said, I could have gone right down to this step by just dividing both sides by 4. Everybody see that? Because 4 goes into 32 and 4. That would have reduced that one to an 8 and that one to a 1. And then 0 divided by 4 stays 0. Okay, that's a much more compact algebra step to me, to do it that way. You don't have to write so much. Okay, it's neater. All right, so now that we've got it down to here, we can focus on which pattern fits. And we already said it's the difference of cubes, right? So we've got to be able to write this as something cubed minus something cubed equals 0, right? So what's going to be the first something? Yeah, it's going to be a 2x, isn't it? Because I've got to find what could I cube and get back 8 times x cubed. Well, the variable part is just going to be the x. What number cubed is 8? 2. You see, now if I distribute the cube, I'd get 2 cubed times x cubed, which is what I need, 8x cubed, right? And then over here, it's just a 1, right? So then this is my A, and that is my B, and I'm literally just plugging those into that formula, right? That's the pattern. Okay? So what's that going to give me then for... I'm going to scoot this down a little bit. So 2x cubed minus 1 cubed would factor into what if I follow that pattern? A is 2x, so I'm going to get A minus B, right? Times A squared. Now, what's A squared? If A is the quantity 2x, what's A squared? The quantity 2x squared. So 2 squared times x squared, right? 4x squared. Good. So that's actually going to be, this part is going to be the quantity 2x squared, which is 4 times x squared. Okay. Plus A times B, 2x times 1, plus 1 squared is just 1. Okay. So that's what this thing factors into. Right? And now we're essentially done.
So that's the whole answer?
Well, no, because remember, we're not actually just factoring. We're doing this for a reason. We're trying to solve an equation.
Kind of a cool symbol.
And I like that. Remember that what we were actually doing here is we were setting this equal to 0, right? So the whole point of factoring these things is to break down that big cubic polynomial into smaller ones that we can deal with. Once we get them down to a point where they're either linear or quadratic, we can finish, because then we can either use chapter 1, 2, 3, or 4 stuff or chapter 5 stuff to get our answers, right? So all we're going to do is set this one equal to 0. That's one solution. Or the other solution would be when this one equals 0, 4x squared plus 2x plus 1. But what do we know about this one? I told you earlier, remember, that this one is never going to have real solutions. So you can always just ignore it. Every time you know that the quadratic factor that's coming out of those difference of cubes and difference of squares factoring patterns is always going to go away. So don't waste your time with it. We would have gotten I's. Guaranteed. Promise. Every time. Yeah.
What kind of job would you use this method?
Don't ask me that right now. But any job that uses any kind of math, you would need to know this simple algebra.
So like a cashier?
A cashier, you wouldn't have to do it.
Well, I mean, is there like a career that uses this formula every day? And like,
Oh, yeah. If you're an engineer, you'd use this stuff routinely. If you were a pharmacist, you would use this stuff all the time. If you were, there's tons of stuff where you would. If you're an accountant,
Mathematician.
you wouldn't. Yeah, mathematician, you would for sure. Okay, so then what's our solution here? Okay, back to business. So if I set this equal to 0 and solve, how do I isolate x? I add 1, divide by 2. So x equals 1/2. That's our solution. Okay. Now that seemed like a lot of stuff. But let's go back. If we look back at what we did, it's not that much. We divided both sides by 4. We talked about that for a while, right? We made it look like a difference of cubes. And then all we did was we plugged in our A and our B into that factoring pattern to get this. And then we just set it equal to 0. We just set each factor equal to 0 and solve those little equations. Okay? All right. So that's the first kind. And that was a pretty hard one of the first kind right there. Okay, let's look at next type. Next type. Okay, what about that? Solve that. First thing we would automatically do would be what? Subtract 8x, right? Put it in standard form so it's all set equal to 0. So if I subtract 8x, and then let's write it in standard form. So we go, decreasing powers of x. So we get x to the 4th plus 7x cubed minus 8x minus 56 equals 0. How many terms in that polynomial? 4. So what's our strategy when there are 4 terms? We're going to group it. Break it into 2 groups. So we've got the first group plus the second group, right? And you guys are old pros at this. We've done this for quite a while. So now, what do we do with this first group? Okay, we're going to break out a greatest common factor. So pull out the greatest common factor. If we pull out an x cubed, what are we left with? What's our leftover factor? Okay, x plus 7. I just undistributed an x cubed, right? Okay, and then what about our second group? Now over here from our second group. Okay, we know the leftover factor has to be identical if it's going to work. So good. So then the question is just, can we do that? Can we pull something out to get that to happen? Yeah, -8.
What if you can't?
If you can't, then you can't factor.
Okay.
Yeah. So we can always check by redistributing. -8 times x is -8x. -8 times 7 is -56. So it works. Okay? And then the whole thing is just equal to 0. Okay, so we've done the hard work. Now all there is left for us to do is break these into separate factors. So I've got the first term with the red and the blue pieces, second term with the red and the blue pieces. The red pieces or the red factors are the same, so I can pull those out. So I get x plus 7 times what's left over then on the left side. I get x cubed plus -8, so that's x cubed minus 8. Everybody see that? Okay. Equals 0. Okay, now that helped a bunch. Now we've got it broken into smaller parts. What about this here? We've got x plus 7 is linear, so we're done with that. Here I've got x cubed minus 8. That's still cubic, but it's a lot smaller. Now, how am I going to deal with that one? If I want to solve these equations, I've got to solve this is equal to 0 or this is equal to 0. Well, that one's not quite ready yet. Okay, it's a difference of cubes. Good, it's a difference of cubes. So if we rewrite this one as x cubed minus 2 cubed, we can factor it, right? A is x, b is 2, and we're just doing a cubed minus b cubed pattern. So what does that break up into?
X is 0.
X minus 2, yeah, that's what we're going to see. X minus 2 times, we honestly really don't care, do we? In a way, we don't care what the second one is. We don't care what the second one is because we know it's not going to have any real zeros, right? The big factor of that factoring pattern never gives us zeros. If we did it, it would just be a squared plus ab, plus b squared, right? 2 squared. But it's not going to work anyway. So what we end up with is that. So this one is never equal to 0. If we find the zeros of these other two, we get x equals -7 or x equals 2. Now, what if we wanted to find all the solutions, including the imaginary solutions? Well, then we could set this equal to 0 and do the quadratic formula. Now, did everybody get that?
Yeah.
I feel like people missed that last little. I kind of let you off the hook and people relax for a second there. Okay. No, it's fine. It's fine. What if, I'm not saying I'm going to do this, but if I wanted to ask you to find all the complex solutions, including the imaginary ones, everybody sees that we could set this equal to 0. If we did that, we won't even do it, but we'll just see that we could. X squared plus 2x plus 4 equals 0. Apply the quadratic formula, and it's going to give me 2 answers back with i's in them, but those would be the answers. I'm not going to probably do that to you this chapter, but I could, right? That's something that we could do. Okay? So does that make sense? Right? So 4 terms we factor by grouping. Okay? Now the last case is 3 terms. Let's look at one of those. So, how about this one?
I got greasy.
Okay, what about that one?
4x to 4.
Okay, so we want to subtract. We probably want to keep the 4 positive. We could pull these terms over to this side, right? We want to keep the leading term positive. So if we do that, if we set it equal to 0, then we're going to get 4x to the 4th minus 5x squared minus 9. Equals 0. How many terms in that polynomial? 3. So what's our strategy? Quadratic. We're going to think of it in quadratic form. Right? Now I could think of this as being 4x to the 4th is really just 4x squared, right?
Sorry, I'm speaking.
Okay? That looks like a quadratic equation in standard form. I've got 4 times something squared minus 5 times something minus 9. So that I don't want to factor that because I've got a 4 in front of my squared thing, right? So I'll use quadratic formula, right? If I have, now you would know, if I asked you, if that was 4x squared minus 5x minus 9, you would all know that x equals negative, right? X equals 5 plus or minus square root, etc., right? But it's not an x, it's an x squared. Big deal. The quadratic formula is just solving for whatever is being squared in this first term, right? It's solving for x squared this time. So we would get then the results. Now, what are a, b, and c in this one? Yeah, a is 4, b is negative 5, c is good, negative 9. So then x squared equals negative b, so 5 plus or minus square root b squared. So we're going to square the positive, right? When we square a negative, we always square the positive. Minus 4 times negative 9, 4 times a times c, all divided by 2 times 4, right? And so we get x squared equals, what is that? 5 plus or minus the square root of 25 plus 36 times 4, so 144. So we get 169. All divided by 8. Square root of 169 is 13. So we'll take both cases. We'll take the plus sign and take the minus sign. If we take the plus sign, we get 18 over 8, right? X squared. We either get x squared equals 18 over 8. What's that reduced to, 18 over 8? Well, as a fraction. So 18 over 8 would reduce to what? 9 over 4, sure. So x squared equals 9/4, or x squared equals, if I subtract, I'm going to get 5 minus 13 is negative 8 over 8, negative 1. So those are the two equations that I could just solve easily now. Those are easy chapter 5 equations, right? So the quadratic formula gave us these two answers. The only additional step is, now we got to see what is x squared, because the answers are in terms of x squared. All right, so, oops, hang on. Okay, what about this one? If x squared is negative 1, what's x? Plus or minus square root of negative 1, that's going to have i's in it, right? So Get rid of it. That's got i's in it. What about over here? If x squared equals 9/4, then x equals plus or minus the square root of 9/4. Well, what's the square root of 9/4?
Square root of 9 over 2.
The square root of 9.
So 3/4.
So, yeah, 3/2. Square root of 9 over square root of 4. So x equals plus or minus 3/2. Got two solutions. Plus or minus, plus 3/2 or minus 3/2. Okay? Not that bad, really, is it? I mean, if you look back at what we did, all we did was quadratic formula, right? Now, we could have factored it if it was easy, but it was just easier this time to use quadratic formula. Okay? Make sense?
Yes.
Okay. How about